Well, welcome to Advanced Math, Lesson 87, Sum and Difference Identities. Uh, these aren't necessarily really hard, but they are maybe they feel strange. They look strange. So I didn't want you to feel overwhelmed by them. So here's the video for you. The argument of trig functions are inviolable is inviolable. Remember we called the argument the pink onion, that little discussion we had. But anyway, they're inviolable. What that means is the sine of 15 plus 30 is not the sine of 15 plus the sine of 30. You can't do that, okay? Obviously, the sine of 15 plus 30 would actually be sine of 45. That you could do. You can add inside the parentheses, but you can't split it into two addition problems. So if you have things added together, instead you need to memorize these equations. You have to memorize these equations. Okay, so here is sine of A plus B is sine A cosine B plus cosine A sine B. So if you have sine of two angles, of the sum of two angles, take the sine of one, cosine of the other, plus the cosine of one, sine of the other. If you have the difference of two angles, you subtract those. Sine A cosine B minus cosine A sine B. Okay? With cosines, it looks a little different. Cosine A plus B is cosine A cosine B minus sine A sine B. The difference of A and B is cosine A cosine B plus sine A sine B. Now, I will tell you, these equations are really important. You're going to need these a lot next year. We will use these next year. So these four equations, we're going to be using them for the rest of this year, which I know is not that long, the rest of the week. But we also are going to use them a lot next year. So you may not memorize them this year, but you are definitely getting, these are important, okay? Let's see how these work. And they do the first one, they do an abstract type one. It's in the form of sine of A plus B. In this case, it's x plus pi over 4. And so sine A cosine B is sine x cosine pi over 4 plus cosine A sine B cosine x sine pi over 4. Still don't know what x is, but we do know what pi over 4 is. That's a 45-degree angle. If you do your conversion, that's a 45-degree angle. So it's going to be 1 over the square root of 2 or square root of 2 over 2. And you'll notice I have a little bit of problems with the square root of 2 over 2 because I don't have really good formatting. But there you are. That's the best. That's what it is. Square root of 2 over 2. So sine x square root of 2 over 2 plus cosine x square root of 2 over 2. And they factored out the square root of 2 over 2 and then left sine x plus cosine x. So that's the answer. Sine of x plus pi over 4 is going to be square root of 2 over 2 times the sine of x plus the cosine of x. Okay, still an abstract answer, but it is somewhat simplified. Now, real practical application, let's say we want to know the cosine of 15 degrees. Well, this is not one of our basic triangles, but the 15 is 60 minus 45, and those do come out of two of our basic triangles, 30, 60, 90, and 45, 45, 90. So we can do this now. So we're going to do the cosine of 60 minus 45, and that answer then will be the cosine of 15. So following our pattern, 60 minus 45 means we do cosine 60, cosine 45, plus sine 60, sine 45. So the cosine of 60 minus 45, cosine of 60 is 1/2, cosine of 45 is square root of 2 over 2, sine of 60 is square root of 3 over 2, sine of 45 is square root of 2 over 2. Okay, I apologize again for my square root signs. So the cosine of 60 minus 45, which is 15, is square root of 2 over 4 times plus square root of 6 over 4. If you look at my multiplication up there, you'll see that that's true. Which means that the cosine of 60 minus 45 is square root of 2 plus the square root of 6 over 4. And that's the same as the cosine of 15. Okay? Really not the kind of plug and chug, but a little bit, thinking through this a little bit, you'll get them. We're going to skip the tangent stuff. So, for example, number 9 on lesson 87, you don't have to do that example, all right? That problem on lesson 87. And any problem for the rest of the year that asks you specifically about the tangent of A plus B or A minus B, we're going to skip those, okay? It's not worth it at this point in the year for us to spend time on that. We'll probably have to deal with it again another time, but not this year, okay? All right, that's your lesson for today. Have a good day.